All right, Mr. Ahmed here for 6.4. Goal for today is to use exponential growth and decay equations. So exponential growth functions come in the form y equals a times 1 plus r. So the reason why this is going to grow is because we're taking 1 plus a specific rate. And then that's raised to t, and t is the time, okay? So this is going to be a growth function. A is going to be greater than 0. And r is going to be greater than 0, so that means it's going to go up, okay? It's going to increase as we're going. So as we take a look at this, a stands for the initial amount. That's what we start with. Y is whatever we're going to end for a final amount. R is the rate of growth in decimal form. So a couple things there with the decimal form. If I'm told it's 10%, we have to move the decimal 2 to the left to get 0.1, okay? 7%, 2 to the left, that's 0.07. So we have to change it to an actual decimal. We cannot leave it as a percent, okay? To change from percent to a decimal, we go 2 to the left. And t is the time, and this is our growth factor, 1 plus r. If that's a number greater than 1, it is going to increase. If it's less than 1, it will decrease. So, we are going to write some exponential growth functions and some decay functions and then evaluate. So that's really our goal. So it says a website has 500,000 members in 2010. So this is the initial amount. That is A. That's what we're starting with. The number Y of members increases by 15%. That's R. We need to change that to a decimal. So R is equal to 0.15. Move it 2 to the left. It says write an exponential growth function that represents the website membership t years after 2010. So we're starting in 2010. So y equals our initial amount, 500, 1, 2, 3. Our original equation, y equals a times 1 plus r raised to the t. Okay, so 500,000 in for a times 1 plus r, 1 plus 0.15 raised to the t. Now I can simplify this down. 1 plus 0.15 would equal 500,000 times 1.15 raised to the t. So if it's bigger than 1, it's a growth, and the rate was 0.15 because it's 0.15 bigger than 1. Now it says how many members will there be in 2016? So for me to figure this out, we have to figure out 2016. We started in 2010. So from 2010 to 2016, t is equal to 6 years. Okay, so then I'd plug that into my equation and we'll see what we get. So we got to plug that in for t. All right, I'm going to use my calculator for this. So right here, 6 going in for t. So I have 500,000 parentheses, 1.15, close it, raised to the 6th. Oh boy, I'm supposed to round to the nearest 10,000. So let's write this out. 1,156,530. Okay, 1, 2, 3, bam, 1, 2, 3. So we have 1,156,530. If I were supposed to round to the nearest 10,000th, that would call it here. So that would be 1,160,000. And honestly, I don't care. If you gave me the full answer rather than this rounded answer, that'd be fine with me. So that would be our new members. So it went up by quite a bit. They're growing pretty well. Okay, decay. The only difference between growth and decay is this is going to be a minus sign. So our decay factor is going to be a number less than 1 inside the parentheses, okay? So if I purchase a car, unfortunately, those things do not typically grow in value. Usually they get to be worth less money, all right? That's typical. 14% annually, I purchased it for $25,000. So in 2010, I purchased a car for $25,000. That's my initial amount. There's A. Decreases by 14%. R is equal to, change it to a decimal, 0.14. Now we're writing an exponential growth function or a decay function, exponential growth slash decay. because this one is going to go down. All right? All right, so here's our original equation. A times 1 minus R. So the decay function has a minus sign in between. All right? I'm going to delete this and say exponential decay. All right? Can't be growth, it's decay. All right. So y equals A, our initial amount, 25,000 times 1 minus 0.14 raised to the t. Now we can take 1 minus 0.14, and that's 0.86. So this number is less than 1. If less than 1 inside the parentheses, decay. Greater than 1 inside the parentheses, growth. All right. Now it says, what's the value of the car in 2015? So 2010 to 2015, t is equal to 5. 5 years. Got to plug it in. All right. Let's see here. So 25,000 parentheses 0.86. Close it. Raised to the 5th. So, in 5 years, my $25,000 car decreased to a value of $11,000. Unfortunately, that's pretty accurate. So, don't expect to be making money off brand new cars. All right, just a couple more examples here. Identify if it's growth or decay, or neither. So, let's see here. All right. X is increasing by 1. Y is decreasing by how much? What's this dividing by? It looks like 30 divided by 3. Let's see, what's 270 divided by 3? 270 divided 3 is 90. So this is dividing 3, dividing 3, dividing 3, which is the same as timesing by 1/3, timesing by 1/3, timesing by 1/3. It's the same as dividing by 3. So it's going down, so this has to be exponential decay. A, I know it's exponential, and B, I know that it's decreasing by 1/3 each time, okay? Our next one, looks like X is going up by 1, and this is times 2, times 2, times 2, so this is growth, okay? And that's all we need to figure out there. Next one, identify each as exponential growth or decay. So I have to look inside the parentheses. Then I'm supposed to identify A and the R, so the actual rate. Okay, so A, starting at 5, 1.07, so that's bigger than 1. So this is growth. Our rate is however far away it is from 1. This is 0.07. Which is 7%. Okay, so I'm writing it both, 0.07, 7%. How far away from 1 were we? Evaluate if t equals 5, so we'll use our calculator for that. 5 parentheses, 1.07, close it, raise to the 5th, 7.01. Got it. Next one, A is 0.2, rate. Well, first off, looking inside, this is less than 1, so this is decay. How far away from 1 is it? It's 0.02 away from 1, which is 2%. And now we're evaluating if t equals 6, so we will type that in. 0.2 parentheses, 0.98, close it. Oh. There we go. Raised to the 6th. I got 0.177. So it didn't go down very fast at all. All right, that's it for today. Have a good one.